Okay, so today we are going to be factoring numbers into all of their basic prime numbers, and we're going to be writing those out in a couple of different ways. So one of the first ways we're going to talk about doing this is by using a tree, factor tree. So at the top of your page, please write your name. I can't give you credit unless there's a name on it. It's just the way it goes. So we've talked about prime and composite numbers, and for this activity, we're going to use prime numbers, and those are very important. So up here, not, well, you can write them next to your tree as long as it's not where your name is. We're going to write down some numbers. So 2, 3, 5, 7, 11, 13, 17. So these are some of the first few prime numbers. It would be a good idea to just have these here because we're going to be using prime numbers a lot today and for the next little while, and it would be a good idea just to memorize those if you can, or at least remember what the first few are. So to create a factor tree, you first plant a factor seed. Just kidding, that would be silly. We're going to write the number you wish to factor at the top of the tree. I already wrote those for you. Choose any pair of factors as branches. Doesn't matter what factors they are, just factors that make that number. So for 72, I know that 8 times 9, we're doing multiplication because when factoring, we're talking about things that are multiplied together. Those two numbers multiplied by each other will make 72. So decide whether each branch is a prime number or composite. 8 and 9 are both composite numbers. None of them are prime. For each composite number, choose a pair of factors, repeat as necessary. Oops, there's a typo, that should say until all the numbers at the bottom row are prime numbers. We're going to add in something right here. We're going to write in circle prime numbers. So when we get to a prime number, we're going to circle it, and that branch of the tree is going to stop. And then it says prime factorization can also be written in exponential form, but we don't have our prime factorization quite yet. So since these are both composite, I'm going to keep going. So with 8, let's see, I know 2 times 4 is 8. Now, I've got this 2 here, and it's a prime number. If you get a prime number, you're going to circle it, and that branch of the tree is going to stop right there. 4 is a composite number, so we're going to keep going. 2 times 2, and those are both prime, so we can circle them. So this branch of the tree that started with an 8 is now done. All of my ends of my branches are circled, but we still have this 9. So we could do 3 times 3 is 9, and I can check up here. 3 is one of my prime numbers, so I can circle those. Now all of my tree branches have come to an end with a prime number. So prime factorization form for 72, always, 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 you're going to listen from smallest to biggest. That's how prime factorization form works. If they're not in order from smallest to biggest, then it's not prime factorization form. So we are going to list them all in order. So I have a 2, and we're going to put dots in the middle because it's multiplying, times I have a second 2 and a third. I'm going to put dots in between all of them. Then I have 3, so times a 3 times a 3. I have 5 things circled and 5 numbers here. Factoring in exponential form, it's just like this, but we're going to make it a little more condensed so it doesn't take up as much room. We're still going to go in order from smallest to biggest. So out of my 2's, I'm going to count up how many I have. I have 1, 2, 3. So I'm going to put a little cubed right there. It means I have 2's multiplied by each other, and there are 3 of them. Still going to put a dot in between, and then for 3's, I have 2 of them. If you just have one of a number, you can either put a 1 there, or you could just leave it just like up here, just with a dot and then that number. And that's it. So we have the prime factorization form and the exponential form. So now for 10, we're going to do, or excuse me, for 100, we're going to do the same thing. So if I pick 50, my other number would have to be 2, because it's things multiplied by each other, not adding. Can't do 50 and 50, because that's a really big number that is not 100. 2 is a prime number, though, so I can circle it, and that branch of my tree is going to stop. Now 50, we could do we do 5 times 10, and 5 is a prime number. Check back to your list. 5 is a prime number, so I'm going to circle it. 10, though, is a composite number. I'm going to have to keep going. So we will do 2 and 5. Those are both prime numbers. We're circling. All of our branches have stopped with a circle, so we're done. So I have 2 2s, so I'm going to do 2 times 2, and I have 2 5s times a 5 times a 5. So in exponential form, I have a big 2 with a little squared sign next to it. There are 2 of them on my list. Put a dot for multiplication. Then for 5s, I have 2 of those also, so I'm going to put a little squared. So that's how you use a factor tree. If you turn the page over, we're going to talk about one more way that we can factor numbers. Some of your teachers call this upside down division. Some of them call it an upside down birthday cake. Either way, we're doing the same thing. So write the prime factorization of each number using division or using an upside down birthday cake. List the repeated multiplication and the exponential form. So that was on this sheet, repeated multiplication and exponential form. So it wants you to do both. So we're going to have to do long division upside down, and we're going to have to write it in 2 different forms. Okay, so for me, I write bigger, so with these numbers, I'm going to have to move them out to the side a little bit. So you're going to start with the number at the top, just like we did for factor trees. But then instead of writing a division sign that goes over the top, we're going to write it where it goes underneath the number, like an L. So with factor trees, you can choose any factors. It does not matter which numbers you pick. With upside down division, you have to only choose prime numbers. That's just the way it goes. If you want to write those prime numbers that we wrote down before up at the top of your page here, that's fine with me. So I know 2 is a prime number, so we can start there. So I'm going to write 2 out in front here. So if I were dividing this, and we can go ahead and circle 2 because it's our prime. 2 would go into 16 8 times. Now I'm going to keep going because that's a composite number. It's not a prime. I can't circle it, so I got to keep going. So make another upside down division sign, and I'm going to use 2 again, and then circle it because it's a prime number. So 2 goes into 8 4 times. 4 is a composite. I can't stop yet, so I got to keep going. So 2 goes into 4 twice. Now if my bottom number is a prime number, then I'm done and I can't go anymore. Let me circle it. So for 16, my repeated multiplication version is going to be 2 times 2 times 2 times 2. And my exponential form is going to be 2 to a power. Count how many we have. 1, 2, 3, 2 to the 4th power. So for 24, I'm going to bring it over here because I need some room to write. I like to use 2s because that's an easy way to start. If it's an odd number, though, you're going to have to see what else will go into it because you can't use 2 for your first one. So 2, I'm going to circle it. 2 goes into 24 12 times. I'll use 2 again, and that will give me 6. If I use 2 again, I'm going to circle it, and it gives me 3. 3 is a prime number. I can circle it and stop. So my repeated multiplication, 2 times 2 times 2, we have 3 of them, times 3. Make sure you're going in number order, 2s and 3s. And then exponent form, 2 to the 3rd times 3. If you want, you can put a little 1 up here. It's your choice. But 3 to the 1st power is the same thing as 3. So we can leave it either way. Okay, 28. I'm going to use 2 because I like 2. And that would give me 14. I'm going to use 2 again. And that would give me 7. If you need to check back on your list or look up on the poster that is above where you sharpen your pencil, it has a whole list of prime numbers. They're those ones that are in red. So if you need to check up there, so 7 is one of those. I'm going to circle it. So I have 2 times 2 times 7, which is 2 squared times just a 7 by itself. If you want to put a 1 there, you can. 26. So it's an even number. It ends in 0, 2, 4, 6, 8. So I know 2 will go into it. I'm going to circle my 2, and then I get 13. So check your list. Is 13 a prime number? Yes. Circle it. We've got to the bottom. 2 times 13. And guess what the exponent form looks like? The same thing. Yeah, go ahead and write it twice because it says list the repeated and the exponential form. And means including both things. So if you don't have two things written, then you haven't done what the instructions say. So people call it upside down birthday cake because it sort of looks like a cake with little tears as they get higher and higher. So you know how to use a factor tree and using upside down division. Two different ways to factor into all of the prime numbers that a number will have. On the next page it says for each number, or factor each number. For odd numbers, that's like 1, 3, 5, 7. That's the left side of the page. You're going to use a factor tree. For even numbers, use upside down division or a birthday cake. For all problems, give your final answer in repeated multiplication and exponential form. So if you want right now, you can divide your page. So odd numbers use a tree. So if up here at the top, I'm going to draw a little tree. And then on this side, we're going to use a cake. Whatever will remind you that this side factor tree, this side use a cake. So we're going to practice both ways. Okay, I did promise some boys in my 4th hour I would do a shout out to them at the end of the video. So here's a shout out for Kai, Jordan, and Matt. Thanks.